Hello, welcome. Uh, Last time I made very few videos due to some technical problem. Now I'm going to complete that whole exercise. We were into discussing Newton's laws of motion, and in the process, we looked at how to solve the problems. Number one, based on dynamics. Number two, it's based on the kinematics also. Without the help of these two, it's not possible to solve the problems. Now, as I said, every time we are given a problem, you are supposed to first work out constraint relation and keep quiet. And I told you that you have two ropes here, therefore you get two constraint relations. And the first one is this: always be careful wherever you have a moving pulley. Moving pulley, wherever you come across, you have to be very, very careful in writing the equations. Now, this using the two-finger technique that I have told you, I'm going to look at this as rope number one, this is rope number two. So for rope one, I would call it as a pulley, and instead of writing the displacements and then velocities, then accelerations, I'm directly writing down those accelerations because there are no complications here. Okay, so what do I do? Now A1 downwards, A2 downwards, A3 downwards, AB downwards. Everywhere I am taking all downwards, downwards, downwards. Remember, whenever we take this and we get the final answer, if you get that as negative, that means the direction you took was wrong, so you have to modify your final answer. There is nothing wrong in taking A1 up, A1 down, A1, A2 down, A1, A2 up, or A1 up, A2. Anything you want, you take it, but write your equations appropriately. And once you write those equations, your final answer, if it is positive, what you took was right. And if it is negative, if you suppose something like 3g by 18, something is 19, you get it. So you got minus. That means probably if you take that as downwards, now the answer must be upwards. Likewise, you make the modifications. I think that's more than enough. So nothing to worry on that count. Now, if you look at the first row, you know that if I use the two-finger technique, so I'm doing it. Look, I'm fixing this. So this is plus A1. This being fixed plus 0, and here plus AP, this being fixed plus 0, the whole thing is 0. Therefore, AP is equal to minus A1 from this. Now look at the second row. Two segments, both edges are moving. Now this is crucial. See, I am fixing this first. You took it down. So what is happening? Segment is increasing. So plus A2. Now I fix this and see what is happening. Segment is decreasing due to the movement of the pulley. So minus AP. Come to this again. Segment is decreasing due to the movement of pulley. Minus AP yet again. Fix this, and then this is A3 down because of that segment is increasing. Plus A3 is equal to 0. Now AP is minus A1. So what do you get? A2 plus A1 plus A1. Now this is the constraint relation. One where I have given all downwards. I mean, this is how while writing the equations also you should develop the equations here, and look at these things one by one. Okay? Now, for example, the same thing I'll show it to you also. If you take it with the help of length from a fixed point, x1, xp, x3, x2. You have taken lengths from fixed points and now write the length of the first row. x1 plus xp. That is length row of this. I told you to ignore these parts because they always remain constant, so we need not worry. Now what is the length of this row? x2 minus xp, right? What is the length of this row? x3 minus xp. This is L2, right? Now differentiate. What do you get? V1 plus Vp is 0. Then this is V2 minus 2Vp plus V3 is equal to 0. If you do that, A1 plus AP is 0. A2 minus 2AP plus A3 is equal to 0. AP is minus A1, substitute, you will get this relation. If you recall, I told you, whenever you take from a fixed point, all those things that you take are either in the downward direction or in the upward direction. That's how you get it. Now, I have shown you how to get this, but the important part is, if they give accelerations, your thing will be completely different. So, A2 plus A3 plus 2A1 is equal to 0 is a constant. Now, everything you took downwards. Let us now look at the dynamics of it. How do you look at the dynamic? Draw a FBD of each one. This is M1G. Remember, this is one rope, this is another rope, therefore the tension here, I'll take it as T1 and you took downwards, therefore how do you write this equation? M1G minus T1 is M1A1, okay? Now there is a pulley also here. This is T1, this is T2, this is also T2. There are 2 points where the rope is connected. So you have, this is going down with AP. So 2T2 minus T1 is equal to 0 into AP. Purposely I am writing because we are taking that as a light pulley. Therefore, you get the whole thing as 0. Now look at this. How do you get that? FBD of that, if you see M2G, T2, A2. So how do you write? M2G minus T2 is equal to M3 in a similar way. M3G minus T2 is equal to M3A3. I have written down all dynamic equations and constraint relation. Now you see how many variables? 3, T1 4, T2 5. 5 variables, now 5 equations you can solve. In fact, as I told you, one easy way to solve, to avoid confusion is, look at the equation having maximum number of variables, this one. In this, substitute everything based on this. Now, for example, you said T1 is equal to 2T2. So how I modify this equation? I write it again for you here. M1G minus 2T2 is equal to M1A1. Now this is as usual. So this I am avoiding so that everywhere I am getting T2, T2, T2. Now the purpose of all this is this. And what is A2? M2G minus T2 by M2. A3 is M3G minus T2 by M3. Okay? Now, although I expected you to solve all this, a few cases I'm giving on my own so that you don't waste much of your time, but you do learn how to solve this at every stage. A2, this one. So, G minus T2 by M2. A3, G minus T2 by M3 plus 2A1. 2G minus 4T2 by M1. All this is equal to 0. Okay? Now you got this. From this you can directly get tension. You see? G, 2G. 4G is equal to T2 into 1 by M2 plus 1 by M3 plus 4 by M1. So how do you get that? M1 M3 plus M2 M1 plus 4 M2 M3 by M1 M2 M3. That's how you got T2. 4 M1 M2 M3 G divided by M1 M3 plus M2 M1 plus 4 M2 M3. Okay? Now, supposing I will give it as a numerical, let this be 1 kg. To simplify matters, supposing if I give it, then what are you getting here? 1 into 2 into 3. 6 into 4, 24. This is 3 plus 2, 5 plus 24, 29. So T2 is equal to 24G by 29. This is how you got it. Now once you get this, you can find out what is T1? 2T2. 48G by 29. So T1 you got it, T2 you got it. Then A1. What is A1? You have this equation, if you remember. M1G minus T1 is M1. M1 is 1 G minus T1. So what are you getting? A1 is equal to minus 19G by 29. Now this is what I was telling you. You have got now A1 as a negative. Therefore, the direction that you took is wrong. What is right? We took it as all downwards, but A1, that one mass will move upwards. So, A1 is minus 19G by 29, or upward. Okay? Now I am erasing this part. In a similar way, we will try to find out A2. A2 M2G minus T2 is M2 A2. M2 is 2, 2G minus 24G by 29 is 2A2. I am substituting for M2 as 2. And what do you get? 29 into 2, 58 minus 24. 34 G by 29. So this becomes, so A2 you are getting it as positive. Positive means our direction that we took was right. So 17G by 29 down. In a similar way, we will find out A3 also. A3 equation is what? M3G. Okay. 3G minus 24G by 49. 29 is equal to 3A3. Now, this is how much? 87 minus 24. So, 61G by 20, 63. 1. So, A3 is equal to 21G by this. Positive, therefore you got this right. Now you see, A1, A2, A3, everything you got. Only thing is A1 is going up, A2 is going down. That's how you have to understand. Sometimes they may ask, what is acceleration of A21? A2 bar minus A1 bar. A2 bar minus A1 bar. What is A2 bar? Down we'll take positive. 17G, because this is along the same line, minus A1 bar is upwards. Upward is minus A2 bar minus A1 bar. So how much? Minus 19G by 29. So how much do you get? 36G by 29. Acceleration is going down, is going up, therefore relative acceleration is much more. So A21 is like this. Hope you have understood this. The signs are very crucial. I may ask you A2P. What is AP incidentally? AP, you know, is minus A1. That means 19G by 29 downwards. I want to know A2 with respect to P. So, A2 bar. So, A2 bar 17G by 29. What do you get? Negative means up. You get the point. Negative is up now. So A2P is 2G up. What is A3P? A3P is, what is A3? Minus, both are in the same direction, so you need not change. downwards. Positive downwards we took. That's only for this problem I took. Now look at some very interesting analysis that you can make out of it. I just redraw the diagram. No issue as far as 1 kg mass is concerned. But here, now this is going down. This is going down. Now, with respect to this, now all of us, when you look at the Atwood machine, when that particular pulley is fixed, you always had that intuition that heavier body goes down, lighter body goes up. Okay? When we did the constraints, A1, A2, A3, etc., one very important point you should remember. Whenever you do constraints, you will get your relations only with respect to a fixed point. We can virtually say they are absolute accelerations, although nothing can be absolute. Keep it aside. But for the time being, we can take them as absolute accelerations. There is no relative acceleration anywhere. Now, what is happening to this? I'll just explain it to you. See, this pulley going down. These are the two bodies. Pulley is going down. This is, let us say, 3 kg mass. This is 2 kg mass. You know how they are going? I'll show you. I'll show it again. They are at the initially same place. That means this is going down more, this is going down less, but both are going down with respect to the ground or with respect to us. But if you look at with respect to the pulley, what is A to P? This is going up, this is going down. What your intuition was telling you a little while ago, if the pulley were to be fixed, is true in this case. Now you get the point? When you take constraints, you'll get absolute accelerations. And when you take with reference to that, you have to be careful. Now a big question arises. Is that the only technique to solve this problem when you have moving pulleys, etc.? Now, of course, we did take it, we solved the problem, answer is over, everything is fine. But you should also at the same time know how to use the different technique. Remember, that's only a technique. If I want to take this to be up, this to be down, with respect to pulley only you can take. That means you are taking a relative acceleration with respect to this. When do you get this relative acceleration? If I look at everything from this reference frame, then what I said is true. But how to apply Newton's first law, which is known as the law of inertia? We made a very detailed mention of the coordinate system there. What was that system? Inertial frame of reference. Non-accelerating frame of reference. Newton's laws are valid. If I take a non-inertial frame, that is an accelerated frame, it could be moving pulley like this or a lift, so many cases. What shall I do? Can I not apply my Newton's, say the second law, or third law, or whatever? That is confined. We know that one to only absolute frame of reference or inertial frame of reference. But that doesn't take away your willing to use the same law even in non-inertial frames. Only thing you have to do is make little modifications. Modifications means if there is an accelerated frame, what are the consequences of that accelerated frame? If I incorporate them into it, then probably I can do it. For example, I take a very smooth body. Let us say that started accelerating, and say you are sitting here on one edge, you're just watching. Once you are inside, you forget that you are being accelerated. Suppose if I'm subject to acceleration, this will tend to move. This will tend to move in this direction. There is no force between these two contacts. That means what? Only this body will go further. How it will go, I'll show you. That is how it has come after some time. Look, this position of the body has not changed. This position of the body has not changed. I am observing from outside. What is happening when you observe it from outside? Now I am observing this cap. With respect to this, it is moving backward. But when you are actually, if I am putting it like this is not moving at all. That is what is happening here, because there is no grip between them to take it along with it or opposite to it. Therefore, this is stationary with respect to any ground-based observer. But what the whole thing is accelerating. Alright? Now, but as far as this person is concerned, suddenly he feels that the body is approaching him. It's a relative motion. Relative to whom it appears to come. He knew, if he is a physicist, he knows that a body cannot move on its own from its state of rest unless a force is acting. Now, what he thinks, I'm just telling, it's only a thinking, remember. These are not necessary at all. What he thinks, let me feel, if the whole thing is accelerating with A, he feels there must be a force acting on this body. If a force doesn't act on this body, how would this body move? So I am now trying to apply Newton's second law here in non-inertial frames. Newton's second law in non-inertial frames, that involves sigma f is equal to ma. Now what does your sigma f consist of here? F real plus sigma f, whatever you are imagining, then you will get mass into relative action. Very, very, very important. I want you to follow my argument little carefully. When you take only sigma fr, you get absolute acceleration. Absolute acceleration. When you take even imaginary forces in any, I write it here for you, non-inertial frames of reference, then you have to take, this is inertial. So that is how you are going to get this. Remember, it is only a jugglery. Many times you don't understand why all this is being done. Right from your childhood, if you recall, when some problems are given, you say that what is the age of son, what is the age of father. He gives some relation between son-father relation at a particular stage, say after 10 years, some kind of such thing, How do you solve that? So when you want to solve that problem, you always try to think, let the age of son be X or let the age of father be X. Something of this sort you used to do. And did you ever wonder that why should I take it as X? What is the consequence of X? What is the greatness of X? It just like it happened, because those days we used to follow and observe whatever the teacher used to say. Okay, let the age of son be x. Therefore, let the father C has become, let us say he may have given 3x. After 10 years, it becomes so and so. So, x plus 10, 3x plus 10, then he may say it is double. So, you equate it and find the value of x. In the final answer, what do you say? You will never say x is equal to 20 or 30. You will say age of son is x. What has happened to x? Without x, can't you do the problem? You can do the problem. You can do the problem, but not at that age, not at that stage. We used x and threw it out. This curry leaves, most of the Indian stuff, they have curry leaves. They keep putting in virtually every other item, but while it comes to eating, they take and throw it out. Same is case with x. I'm sure x must have felt very bad. All these bloody human beings have used me and threw me out. Why x? No answer. But you used x. You're forced to use x and you are getting the answer. And finally, you are throwing in a similar way. When I am here and the body to me, it appears to move towards me, I take as with what does it move? Now, if you really observe, it is moving with the same magnitude of acceleration A, but in the opposite direction. It is going with 2 meters per second square. This fellow finds it to approach him with the 2 meters per second square. And there are no other forces, all other forces are in equilibrium. So there is no horizontally on this body, if I draw inertial FBD, what do you write? I said vertically I am not doing anything for the time being. Actually, there is a normal force, there is mg, everything you have to do. In the inertial forces, no forces acting, no FBD. There is one force here, one force there. Non-inertial. So, which non-inertial? This is the frame. The moving body, it's a moving body in the sense, the moving car or vehicle or whatever, that itself is the frame. If that is the case, what do? I imagine, on this. Now, I am imagining a force which will make it to accelerate with a value equal to A and relative to him. So, he gets an idea like X. He says, why can't I use a force which is acting away from the direction of acceleration like this, and this is the force M. So MA here is inertial force. Is the frame of reference. This is the MAF. F stands for frame. So MAF is like this, acting like this. This is a non-inertial frame. And what is the acceleration? This is the only force, therefore here is to be backward or forward like this. Now, how do I write the equation? Sigma F real 0, sigma F inertial is this, mass into relative acceleration. Now, this force is only due to the movement of the frame of reference. Therefore, it is called inertial force or pseudo force or fictitious force, imaginary force. Each book gives in its own way. all this, what does it indicate to you? It just indicates that if you take an accelerated frame and you want to actually apply Newton's second law, by being in accelerated frame, I am introducing, just like I was using x and then neglecting it, I was using, I started thinking of using an imaginary force or an inertial force. How do you take this is the simplest of all the inertial forces I am talking of. Simplest of all. I will definitely discuss about inertial forces a little later. Now, when you talk of that one inertia, how is that inertial force? Mass of the body into action. Okay, we will say, instead of frame, we will say system. It becomes easy for us. It is acceleration of the system, but in the opposite. Okay? Now, if AS bar is like this, inertial force is minus MAS bar. Now this is very crucial, very, very crucial. And whenever you use inertial force, you will get only relative acceleration. Because you are doing everything with respect to this, your acceleration also must be with respect to that. Okay? Okay. I'll put a stop to this here and continue